All right, everybody. 12.4 is really a really long and really difficult section here. This is really the only textbook I've taught geometry out of that decided to put these two ideas together into one section instead of splitting it up into two, which seems like a really dumb idea to me because both of these ideas are really difficult. So we broke this up, and in part one here, what we did in this video and then on this homework assignment is just dealing with the angle measures that are formed within a circle when you've got either two secants or two tangents, or one of each, that intersect each other. And what's going on in problem number one here is that we've got two chords. We've got chord DF, that goes from here to here, and chord PE. Now, if we were to extend those line segments and make lines out of them, they would be chords. They would be secants. As it is right now, they're just chords. And they are intersecting at a point called C here, which is located inside the circle. Now again, they're asking us to find the measure of the angle indicated. There's this question mark, so again, we usually like to just put an X right there. And the main idea at work here, guys, when you have two chords intersecting inside a circle, the measure of this angle formed here, which by the way is also the measure of this angle formed right over here because they're vertical. That angle right there is the average of these two arcs that are formed. Now those two arcs are important because this 170 is the arc formed by that x degree angle, and the 66 degree angle is the one formed by that angle. Now you've got two angles right here that would intercept arcs PD and FE. This angle right here, I'm going to erase this in just a second, but this angle here would be the average of this arc PD and this arc here FE. But let's get rid of what we have in red and just focus on what's going on in purple because I've already made this more complicated than it needed to be. Okay, so as we said, guys, when two chords intersect inside a circle, the measure of the angle formed is equal to the average of the two arcs that it cuts off. So let's translate that. The measure of the angle formed, that's x, is equal to the average of the two arcs that it intercepts. And the way we find an average of two things is we add them up and then divide them by 2. And the two arcs we're going to be adding together here, the x here gets us a 170 degree arc, so that's here. And then the x on the other side gets us this 66 degree arc, and that's going to go right there. So this is the expression that we now need to simplify. And I suppose we can do that all at one step right there in our calculator. So let's go here and let's see where we were at. I set this up as a fraction, and our two arcs there were 166 added to 70 degrees, and then we had a 2 on the bottom. Let me make sure. Sorry, guys. No, I lied. 170 plus 66. Better go back and fix that, although I think the answer is going to be the same. 170 plus here we go, 66. Yeah, still gets us 118 there. So that is the measure of the angle formed inside that circle. Now, I almost slipped up right there and said a central angle. This angle X is not a central angle because point C is not located at the center of the circle. So that's important to understand. This angle is not a central angle, nor is it an inscribed angle. This one is just kind of floating around somewhere in between. So that's how we handle a problem like 1, and I believe 2, 3, and 4 are similar. Now let's see what's going on here in this example as we look at problem number 5. Now this setup is a little bit different here, everybody. In this case, we have a secant, that would be line JK, and a tangent, which would be line LK. They intersect at a point right here, K, which is located on the circle. So that's in a big contrast to problem number 1, where the point of intersection here was inside the circle. That's when we did that the angle formed was half the sum of your two arcs. But here, our point of intersection is on the circle. And what this is, everybody, maybe not exactly, but this is very similar to what happened when we had inscribed angles that we talked about back in section 12.3. So we're trying to come up with this question mark here, the measure of angle LKJ, which we'll go ahead and we'll call X right over here. And the big idea at work in this problem is that when a tangent and a secant intersect on the circle, the measure of the angle formed is half, once again, the measure of the arc that it creates right over here. So to do this, we need to figure out the measure of minor arc JK And then from there, we can work to find x. Well, the nice thing about a problem like this is the entire circle, which of course we know is 360 degrees, is only cut up into two arcs. And one of them is known at 208. So we can come up with the other one pretty quickly. We would just take 360, which is the known total, minus 208, which is the piece that we know, and we're going to get a 152 degree arc over here on the left-hand side. So that is the measure of minor arc JK. And now if we want to go ahead and find x, let's translate again what that theorem told us. The measure of the angle formed, so that's x, is equal to 1/2 of, or times, the measure of the arc that it cuts off, which is the 152 degree arc over here on this side. So all we have to do, guys, is take half of 52, and that is going to get us 76 for the value of what we called x right there. And that is our answer. A real quick way to verify this, everybody, would be the following. Let's take a look. Let me call this angle over here y. Well, using the same rationale that we just used, y would equal 1/2 of the arc that it intercepts, which is this 208 degree arc right over here. Half of 208 is 104 degrees. So now if we take a look at this diagram, what do we know? The x right here, or we believe we know, is 76. Y, we believe we know, is 104. And I don't know if you noticed, but those two angles right there, 76 and 104, are supplementary. If we add up 76 plus a 104, we're going to get 180 degrees. And since these two angles together form a straight line, that makes all the sense in the world. So that's a nice little way of verifying what we thought was correct in problem number 5. 6, 7, and 8 are similar, so let's move on to number 9. Now this is actually going back to the same concept that we discussed in problem number 1. We've got two secants intersecting at a random point inside the circle. Q is not a central angle, nor is it an inscribed angle. But we have an 85 degree angle formed here. In fact, we have two 85 degree angles, and we know the measures of the two arcs that are intercepted by those 85 degree angles. This is just more complicated because we're dealing with some variable expressions here and not just with straight up constants. So we're going to translate the theorem the same way that we did before. When you have two secants intersecting inside a circle, here's the idea at work. The measure of the angle formed is equal to the average of the two arcs that it cuts off. Let's translate. The measure of the angle formed, the angle is 85 degrees, is equal to the average of the two arcs. Average means that we're going to add two things together and then divide by 2. And the two arcs that we're adding are right here, 38x plus 1. That's one of the arcs. And the other one then, down below it, is 18x plus 1. So it's the same concept that we used in the first problem. It's just a lot more complicated in terms of how much is going on there on the right side. All right, so let's try to solve this equation. I think the first thing we're going to do is try to clean up the numerator on the right. So on the top, we've got a 38x plus an 18x. That is going to get us a 56x. And then for constants, we're adding a 1 and another 1, so that's going to be a plus 2. What we probably ought to do right now is get rid of that 2 on the bottom of the fraction by multiplying both sides by 2. Now when we do that, this 2 and this 2 are going to cancel each other out. And that left side now, 85 times 2 is going to get us 170. And that's going to equal 56x plus 2. Okay, not too bad from here. We're going to subtract a 2 from both sides. Those will cancel. And that is going to get us 168 is equal to 56x. And the last thing we'll need to do here is divide both sides by 56 and hope that that one works out nicely, but I'm pretty sure that it does. Let's check it just to make sure. 168 divided by 56. 168 divided by 56. Yep. Gets us 3 right on the nose there. So x is equal to 3, and that was the answer we were hoping to see right over there. Okay, so that was number 9, and the last one we're going to do together is problem number 13. Now, this is a tough problem here, everybody. What you are dealing with for the first time out of the 4 problems that we've done so far is 2 tangent lines. We've got a tangent that goes from V to U, and technically that's a tangent segment, but if we extended it in both directions, it would be a tangent line, or in one direction would be a tangent ray. So you've got one point of tangency right here at U, another point of tangency right here at W. And what happens is that we've got an angle formed right there of 10x minus 10. The measure of this inner arc is 10x plus 10, and then the measure of this big outer arc here is 26x plus 26. Boy, a lot of repetition within the numbers right here. Okay, and now for the first time, I believe here, we are dealing with what happens when 2 tangents, or really the same if it's 2 secants or a secant and a tangent, what happens if they intersect outside of the circle? And in this case, the theorem in our notes here on 12.4 part 1 says the following, that when your point of intersection is outside a circle, the measure of the angle formed is equal to 1/2 of the difference between the 2 arcs that are formed inside that angle. So let's translate. The measure of the angle formed. Well, the 2 tangents intersect right here to form an angle of 10x minus 10. So the measure of your angle formed is equal to, and this one now, instead of half of a sum, is going to be half of a difference. So we've got to put a minus there and not a plus. Now, you noticed here on the last problem, when I went to do half of a sum, I put parentheses here and here. Now, that wasn't necessary when you're adding, but in a problem like number 13, when you're subtracting polynomials, it is absolutely essential that you put those parentheses there in each spot. If you don't do that, you're going to make a mistake right here in the algebra and end up with a wrong answer. Now, another thing that matters when you're subtracting that didn't matter when we were adding is what order we subtract these in. What you guys can see here is that this circle is cut up into 2 arcs. And this one that I'm highlighting in yellow is what we call the outer arc. It's farther away from the vertex of the angle compared to what's going on right here from U to W, that minor arc, which is the inner arc. That's the one that's closer to the vertex of the angle. So it's essential when we do this that we take the outer arc, the bigger one, 26 plus 26 in the 26x plus 26 in this case, and we do that first, minus the smaller inner arc, which is going to be a 10x plus 10. If you do that backwards, guys, you're most likely going to end up with a negative value for x, which could be possible in some cases, but most of the time is not. All right, so let's see what we can do to clean up this, but that's our setup here. Little work to do on the right. So we've got a 10x minus 10 is equal to, let's see, we've got a 26x. Actually, let's remember what we're doing here, guys. We're really distributing a negative right there, or a minus. So this is 26x minus 10x. That's going to leave us with a 16x. And then for constants, we've got a positive 26 minus 10. We're distributing that negative. So a 26 minus 10 is going to get us a positive 16, and all that gets divided by 2. Now, in the last problem, I told you to go ahead and multiply both sides by 2. I still think that's a good idea. But in this case, everybody, since both 16x and 16 are even numbers, they're both evenly divisible by 2. So I'm going to go ahead and do something else that you're allowed to do right here. I'm going to leave the left side alone, and I'm just going to treat this as 16x divided by 2, which is 8x, plus, and now do 16 divided by 2, which is 8. That's something people don't always realize that they're allowed to do. I wouldn't have done it if, say, this 16 was a 15, because now I've got a 15 divided by 2, and you end up with something ugly. Okay, from here, hopefully not too bad, guys. We're going to subtract an 8x from both sides, and at the same time, I'm going to add a 10 on both sides of the equation. 8x's cancel on the right, 10's cancel on the left. So we now have 10x minus 8x, which is going to leave us with a 2x, equals, and on the right side, the 8 plus 10 is an 18. We're going to divide both sides by 2 and end up with a solution here of x is equal to 9. And that's the answer that we were looking for. Okay, so that takes us through number 13, 14, 15, and 16 work in a similar manner there. So give that a shot, check all your answers, and let me know if you guys have questions. It's a tough section, so keep working hard and have your notes and the videos next to you as you're doing it. Good luck, everybody.